Why can't we make every day more interesting? When will everything work together? When will we have what we need? When will we connect with what really matters? Why do we have to wait? When we connected the phone to the internet, the phone became smart. When we connect billions more things, life will be even smarter. So why wait?
Good morning. My name is John Carville, and on behalf of Qualcomm, I wanted to welcome you to our Computex 2015 press event here this morning. We have a very busy morning for you. We have lots of great speakers. We have some announcements we want to share. We have some perspectives we want to offer on the competitive landscape. And we really are excited to bring everyone here today to not just talk to you about it, but show you about it in a little more detail. So before we get started, what I wanted to do is introduce our speakers and talk a little bit more at a high level what they're going to cover, and then we'll get rolling. So our agenda this morning, we're in the welcome and introduction stage, but then next off is going to be Tim McDonough, our Vice President of Marketing. And Tim is going to cover really at a very high level what we call the Qualcomm advantage. On top of covering some of the announcements we're making here at Computex, Tim is also going to talk a little bit about our perspectives of the competitive landscape, where we see Qualcomm winning and why. And not just talk to you and show you what we're doing, he's also going to give you the opportunity to see it firsthand. So after this press conference is over, we have some phenomenal demos that we want to show you to really help bring this to life of what we're here talking about at Computex today. Then from there, we're going to move into Irvin Guy, our Vice President of Product Management, to talk a little bit more about our Wi-Fi technologies, multi-user MIMO. We have an exciting announcement this morning. Also going to show you from a competitive perspective why we think this technology is really world-class that we're bringing to market and what we think some of those key benefits are. Then we're going to wrap things up with Peter Carson, our Senior Director of Marketing. And Peter is going to cover at a very high level some of the things that we're talking about on the cellular side, especially key technologies here in Asia like uplink carrier aggregation, which sound really complex, but Peter's going to bring it home and put it to you in terms that really what some of those benefits are going to be for end users, consumers, operators, and our customers alike. From there, we'll go into a short Q&A where we'll give you an opportunity to ask some questions. And then we're going to wrap things up and give you plenty of time to see some of the cool demos we have here on site and that we also have next door on the cellular and applications processor side. I'd really encourage you to see those demos before you leave today because it helps bring a lot of the things we're showing here to life. We're not just going to put up things on charts and show you some of those competitive areas that we shine and why. We're going to show you. And that's a big difference to how a lot of other companies do things. So then from there, we're going to move on to departures to bring people back to the Taiwan International Convention Center. So once again, I wanted to thank you for starting off Computex 2015 with us here this morning. Really excited to have you. And I wanted to introduce Tim McDonough and ask him to take the stage. Tim?
So thank you for joining us this morning. I know it's quite hot out there and there's a lot of traffic and a lot to do. So we really appreciate your time. I'm going to talk about the Qualcomm advantage. And I don't really want to talk about our advantage per se and just sort of talk about Qualcomm. I want to answer some of your questions. And these are questions that I get traveling around the world. A very common question is, Qualcomm, you've built a real leadership position in LTE over the years. Your competitors now say they're shipping LTE. Have you lost that advantage? Another common question I get is, your competitors are now talking about shipping SoCs with 10 CPU cores. You've only got 8. You must be behind, right? We're actually quite confident in our position, but confidence without backup is just sort of bravado. And so I want to show you, as John said, the data. So we will take you through an analysis of features, because when you talk about something like LTE, it's not a check the box feature. It's not I have LTE or I don't. LTE has hundreds or thousands of features depending on the generation you're looking at. So we'll look at feature completeness of LTE. We'll also look at feature completeness of our SoC in total. Then we'll look at sort of the statistical performance. What are the benchmarks we believe and say about our performance versus our competition? And then probably the most important, because numbers on their own can be used to mislead, we want you to see how these products perform. We want you to be able to say, I haven't just seen a benchmark score or a chart on a slide, but I've watched a phone with Snapdragon and a phone with a competitor, and I've seen graphics be better, I've seen photography be better, I've seen connectivity be much faster. Because at the end of the day, that's what Qualcomm's customers, our OEMs, care about, and it's what your readers care about. They want to buy a better phone based on your advice. They don't want to buy a phone that has a better benchmark but performs worse in reality. So that's really why we're here today. Hopefully at the end of this, you'll be the judge of Qualcomm superiority, not us, and the facts will be here for you to look at. I think there's $3 to $4 million worth of LTE equipment sitting in the room next door. We typically don't bring quite that much kit with us for a press conference, but we really want you guys to see it. So if you want to understand LTE, Qualcomm's the company to really give you the insight. And there's several Rolls-Royces worth of equipment next door, so make sure you do check it out. And I think you'll learn quite a bit. So we do think when it comes to LTE and the SoC in total, there is really Qualcomm, and then there's everybody else. This is a highly competitive space. We take our competition very seriously. They're running really fast to catch us. It's incumbent on us to run faster. And that's been true in mobile for a long time, but it's equally true today. One of the ways the rubber meets the road for us is not in winning benchmarks, but really in customer satisfaction and customer preference. That, at the end of the day, is what's going to get somebody to look for another phone with Snapdragon after they've had their first, and then another phone with Snapdragon after they've had that one. And if you go to China, which is a critically important market for all of us in this industry, there's a 45% consumer preference for Snapdragon versus our competition. This is statistical based on market surveys. We use third parties to perform. And that is a 45% preference over MediaTek, Intel, and NVIDIA. Certainly, at least one of those companies spends more than most companies make in the market. So we're actually quite proud of the consumer preference because it comes from the superiority that's in our products. So I'm going to start with connectivity, then I'm going to bridge over and talk about processing. But connectivity is just, the marketplace has a voracious appetite for it. It's being driven by many things. It's being driven by social media, it's being driven by just greater mobile web use, greater complexity of mobile web pages. But the killer case is 4K video. There are already hundreds of millions of phones shipping today that capture 4K. The vast majority of them are Snapdragons. And if you look at just the pixels required to paint the screen, not even just thinking of getting the data off the phone, from 2009 to 2014, there's almost an order of magnitude increase. And this is the torture test for mobile because it tests the entire SoC and it really tests the networking capabilities and the connectivity. So that's what's driving demand and that sort of connectivity arms race that's going on in the marketplace between carriers and companies like Qualcomm. To meet this demand requires some advanced techniques, and one of them is carrier aggregation. So when you judge Qualcomm and you say, does Qualcomm have market-leading or parity LTE? Look at carrier aggregation and how far ahead we are in that particular space. And for those of you that aren't super technical, I'll take you through a real basic explanation. And thankfully, my more technical colleagues trusted me with this analogy. But think of carrier aggregation as bringing together multiple lanes of a road or multiple highways. So when you don't have carrier aggregation, the carrier is limited to transmitting data along one highway. What carrier aggregation does is lets the carrier take two non-contiguous pieces of spectrum, bring them together, and use them simultaneously. So this simple analogy would be 2x CA, so two bands being aggregated for more throughput. Of course, we support 3x CA, and there's a lot more complexity that my colleague Peter will take you through. But this, at the end of the day, is what's important because it leads to better user experiences. I'll make you watch that again. For users, it's better user experience. It is important to break that down a little bit. It is things like downloading or uploading content. So we have to look at uplink. You'll hear us talk a lot about. So social media and sharing photos and videos, that 4K video maybe you just shot, you need to get it off the phone, and you want to get it off the phone without a wire. With a wire is kind of lame. That's not mobile. So you need faster upload, you need faster download. As more and more consumers use the cloud to store files when they're mobile, you need very, very fast downlink. You need websites just to move much more quickly. If you just look at the complexity of any of your websites from 5 years ago to the complexity of what it offers today, it's a much richer experience. It's much more demanding on the network. And then finally, you need streaming to work really well. That's another torture case, particularly for streaming HD video or eventually 4K video. Without carrier aggregation, you can't stream 4K. It's broken. So it becomes a market requirement pretty quickly. On the operator side, there's a totally different set of benefits. They're fairly straightforward. They're obvious when you look at them, but they're very important. Operators get more network efficiency. They get more capacity. They get the ability to more finely manage the network because they can manage it more precisely. And they can, when their network is not loaded, they can support new services, which opens up new revenue streams for them. This is almost a perfect storm where you have such strong benefits on the consumer side and such strong benefits on the carrier side. That's why carrier aggregation is going to grow so quickly, because everybody wins. The consumer wins and the carrier wins. And that's what's going to drive this market. Peter will share with you some statistics. When people see these, they're typically surprised. They say, I had no idea the market was moving that quickly. This is a key component of Qualcomm's lead because we're always investing ahead of the marketplace. Now, here is the ugliest slide we will see today. But I think it's important, and let's start with facts. And we're going to look at just feature completeness is where I'll start. Then we're going to move on and we're going to talk about the quality of the implementation of those features. And then we'll talk about user experience. So this is the typical marketing check-the-box feature list. Obviously on the left is Snapdragon. Competitor A is based in Taiwan. Competitor B is based in Santa Clara, and competitor C is based in Korea. That sounds like no further hints are required. So let's just walk through this. So let's just talk about product and integration. Integration is a word that Qualcomm's probably used almost more than any other one. Because it's critical to deliver a cost-effective smartphone or a cost-effective IoE device. You must integrate. You must have your connectivity integrated with the rest of the processor. Qualcomm integrated LTE into the processor in 2011. I had a lot more hair in 2011. It's a long time ago. One of our competitors has finally caught up, and they have been able to integrate into the SoC for the first time. It's very, very hard, and it's the kind of thing you must do many times to get it right. Our other two competitors haven't been able to achieve that yet. That's an advantage. Let's talk about the tech node. People very often talk about the technology node on the core part of the SoC that's the processor, and they kind of ignore the modem very often, largely because they haven't been able to integrate the modem. But Qualcomm has a distinct advantage here, including versus a competitor that likes to talk about node leadership. They don't have it on the modem. They haven't been able to get node leadership on the modem. It's been too complex for them. So Qualcomm has a distinct node leadership on the modem, means lower power and better performance. And I'm going to dig quickly into 4G and 3G, and then we'll talk about Wi-Fi. Qualcomm's leading on particularly Cat9 support, and Peter will share with you the number of Cat9 devices our OEMs have already shipped. It's quite astounding, and it's quite astounding the diversity of those devices, including in places like China. Very often people say, well, Cat9 is just for the Western world. Maybe it's Korea and Western Europe and the United States. And the answer is no. Cat9 is moving very quickly in China as well. So Qualcomm has a lead there. RF multiband support. What is this? You may have heard about the Qualcomm RF360 front-end solution. It's Qualcomm's belief that if you can't manage the RF front end, you're not going to be very successful in LTE. We have the ability to let our OEMs build a phone that supports all bands. So you can theoretically create a single SKU you ship to every single country and have much lower operational costs. And your consumers who bought those phones would have phones that worked anywhere in the world. Qualcomm has that, nobody else does. LTE broadcast, carriers are beginning to roll that feature out. It's starting typically around sporting events and broadcasting additional content at sporting events. Things like football games, car races, tennis matches, and so forth. Major carriers are rolling that out this year. Qualcomm has it, nobody else does. And then you can see there's general Qualcomm leadership around things like beamforming, VoLTE, again, an important service that carriers are beginning to roll out in multiple markets around the world. Qualcomm has VoLTE power management. One of our competitors does, but the other two do not. And then Wi-Fi handover is another important feature. If you're on a cellular call and you want to go into your home or your office and you want to hand that call off to Wi-Fi for efficiency, Qualcomm can do that. Two of our competitors can't. So just a little bit on the feature differences on LTE. Now 3G is also very interesting because a lot of people think 3G is gone. But for anybody that travels a lot or that doesn't live just in the Western markets, 3G is absolutely critical. It's what you fall back to when you're not on an LTE network when you leave an urban area, and it's also what you may bump into when you're roaming. And Qualcomm's continue to invest in 3G because we think it's an important backstop to LTE. It appears that our competitors have actually stopped, and that'll be very apparent when I show you the performance data. And you can see, again, only Qualcomm has, actually have twice the uplink speeds for uploading photos on 3G when you fall back. We're the only ones that support CDMA 2000. One of our competitors supports TD-SCDMA, and we're the only one to have done HSPA plus power enhancements. And then on Wi-Fi is equally important as well, because when you're roaming or you're outside your home or your office, you're on LTE, but when you're in your home or your office, you want Wi-Fi for offload. And that means just like you need the latest LTE, you need the latest Wi-Fi as well. Qualcomm offers that. We're the only offering 802.11ac multi-user MIMO, and we're the only company offering 802.11ad, which is built into the A10 reference platform. So this is a very simple way. This is the check-the-box view of who's got what features, and Qualcomm's, we're very comfortable with our lead, and we'll have to keep on moving fast. Let's break it down, and I'm going to go competitor by competitor. So competitor A is in Taiwan. Let's look at the quality of the implementation of LTE. These slides probably don't do a good job calling out just how big the numbers are, so I'm going to point them out without falling off the stage. The Snapdragon 810, the X10 modem in that has 53% higher LTE downlink than our competition, 50% better. That's almost like comparing LTE to 3G in some ways. So there's a significant advantage there. On 3G with HSPA+, we're 25% faster. On TD-SCDMA in China, we're again 45% faster. Those are huge differences. It's the difference between a race car and a not race car. So that's performance. Battery is the other thing that's very important because it's very easy to drive a ton of performance and guzzle a lot of gas and burn a lot of battery. So you have to balance those two. That's the art of making mobile work. And the X10 consumes significantly less power than our Taiwanese competitor. 48% better on LTE, 27% better on voice. Those are huge differences. When you're trying to make sure you can get to the end of the day, like can you make it home at the end of the day before your phone dies and you're on that last 10%, 48% is a huge difference. That's the difference between making it and not. And then call quality is also important. And these are metrics that it really takes an engineering team to be able to measure and look at, to be able to see some of them next door, which is why we have all the test equipment. But our competitor on a voice call actually has a 20% failure rate. 1 in 4 times, the phone does not make the call. So you may think, oh, it's the network, maybe that inside, maybe it's the other guy who was calling that couldn't complete the call. No, it's your modem, 1 out of 5 times. That's an important metric because we still use our phones to make calls, usually when we're kind of desperate. And it's also an important metric for carriers because when consumers have a call drop, who do they blame first? They blame the carrier. And so carriers, we think, are increasingly going to focus on this metric around the maturity of LTE, and they're going to favor devices that help them create a good impression of the network, and they're not going to like the ones that make them look bad, because it's actually not the carrier's fault, it's the modem. Competitor B from Santa Clara. Again, same kind of story, slightly different numbers, but we're just giving you all the facts here. 30% faster LTE, 25% on data overall. First stat was uplink. Going back to 3G, 186% faster on Qualcomm. Again, we continue to invest in 3G. We think our competitors have not been able to do it. They focused all their efforts on LTE. Power consumption, that balance story is still very critical. X10, 14% better on LTE data power, so these guys are doing a little better until you get to standby, and they're 147% behind. And we have better power on voice calls. Again, these are the kind of things that make the difference between your phone dying mid-afternoon versus making it to the end of the day. And then call quality, 13% failure rate here. So a little better than the 20% on the last. Again, 13% is a big number for a carrier to look at. And then finally, competitor C. Again, same basic story, about a 20% lead, 21% lead on LTE network downlink, 31% on bidirectional. Bidirectional means I'm sending and receiving at the same time. We do this all the time. And then, again, it looks like they've stopped investing in 3G. We're 79% faster than they are. On the power side, similar story. We're about 10% better on LTE, significantly more on 3G. And this company has a 15% call failure rate. So again, significantly better results for Qualcomm. Our call failure rate in all scenarios is 0. So that's a little bit of a look into cellular. I'm going to talk briefly about Wi-Fi, and my colleague Irvin's going to go much more deep into it. But there's a key concept here that's important that I want to talk about. Just as we said, you can't really be in the LTE business without an RF front end. Another thing we believe is really important is you can't be in either mobile or a lot of the IoT businesses without really mastery of cellular and Wi-Fi. And the reason why is that those two technologies, you have to use both of them in combination to get great performance. So you need both those assets to meet the demand for data. You also are seeing a lot of these devices converge. And they may be, particularly ones that are mobile, are going to want to be able to use both of those types of data, ways of transmitting data. This very importantly for us is not a vision slide. This is actually an execution slide. So a lot of companies may talk about this. We've actually done the first 3 stages here. So the first thing we've done is we have something called a connectivity engine that lets the phone or the modem manage between cellular and Wi-Fi and switch back based on what's going to be the best connection. We then have a coexistence manager, because when you put more radios in a small device without management, they fight with each other and they create interference. We then have begun integrating support for carrier services. So that example of a VoLTE call or a video telephony call that you may start on LTE from the cellular network, and when you get to your office, you want it to hand off seamlessly. Qualcomm has a significant lead there. And then what's coming next is you've probably heard us talk about things like LTE-U, and that's actually sharing unlicensed spectrum between Wi-Fi and LTE, and that's another technique where you have to have mastery of both LTE and Wi-Fi to be successful. So this is part of why we're very confident in our ability to continue leading on connectivity. Announced just this morning is also that we've brought out our Wave 2 802.11ac multi-user MIMO products. There's significant new features in there. We've brought multi-user MIMO into the 5 gigahertz band. We now support up to 160 megahertz channels, up from 80. And probably even more important than the specifications and the features is the number of companies that are using this technology from us. That's where success really lies. Irvin will share more details, but we have leaders across the access point space, both in the enterprise and the consumer retail space. We have leaders in mobile, and we have leaders in the PC ecosystem, all using our 802.11ac multi-user MIMO. So with that, I'm going to sort of change gears briefly, and I'm going to talk about Snapdragon. Let's talk about the processor. And a key tenet of mobile is you must balance your connectivity with the processing capabilities of the processor. And so if I take Snapdragon 810 as an example, Snapdragon 810 has the ultimate in connectivity from us. So we've given you the ability to onload and offload massive amounts of content. And then the processor itself must be able to process and display that content. And in fact, the processor is a creator of a lot of that content. And the example that is for us, the torture test is 4K. So I'm going to go a little bit more into 4K. 4K is, in the PC world, if it was graphics that was the challenge. In mobile, it's 4K because it touches the entire SoC, including the connectivity. If you think about 4K, 4K is video. It's 30 frames a second, and every single frame is an 8 megapixel picture. It's just massive. I mean, if you think about the phone of yesterday trying to take a bunch of 8 megapixel pictures, it would choke after a certain number of frames. We're taking 30 of them a second. That's about 3 billion bits per second of data, or about 7 times the complexity of just showing 1080p, one generation behind. It's about 10 gigabytes of memory bandwidth, and it's a systems problem. And so this, I'm going to go back to the opening question that I said I was going to answer for you about, do you feel like you're at a disadvantage because you don't have more CPU cores? Absolutely not. The way you deliver a new feature like 4K is not by adding more of the old stuff that you've already got 8 of. Going from 8 to 10 of the same thing doesn't deliver new experiences. In fact, it's probably going in the opposite direction of what makes sense. Because as you put more CPUs in, to ship the same size and hit the same price point, you have to take other stuff out. And so when you put more CPUs in, what have you lost? You've probably lost a bunch of the stuff that's really important, like graphics capability, like connectivity, like the digital signal processor that gives you better performance for audio. So adding more of the same old thing is not a way to build something new. Our approach is really to look at the entire system and say, if I'm going to do 4K, and this is a historical example, I need to look at the memory subsystem, the system fabric. I need to look at the ISP for capture. I need hardware-based H.265 compression, and a whole list of things. And the statistic here on H.265 is interesting. As we're talking about CPUs, we in Snapdragon 810 and some of the previous versions have a little IP block that does nothing other than H.265. We do it in hardware. Dedicated engine for that. If you try to do that on the CPU, you can. It's a general purpose compute engine. But our hardware block is 50% lower bandwidth and 75% lower power than trying to do it on the CPU. You can use the CPU to do it, but it's going to be worse. So our real art is looking at system design to deliver better experiences, not just more of the same old thing. And let's talk about the results and what does that turn into for users. And same thing we did in connectivity. I'll show you statistics and then I'll show you experience. On the experience side versus competitor A, so this is the premium tier of our Taiwanese competitor's product. They like to compare it to Snapdragon 801. If you just go to a benchmark like the GL benchmark ES 3.1 Manhattan, this is a benchmark we like because it doesn't just spit out a number, it actually shows you something. It shows you graphics working better or working worse. We have 2x the performance just on the output of that benchmark at the end. The real payoff is in smoother visuals, of course. It's just, nobody cares about a number, you care about what you can see. We have significant leadership in the camera, particularly around using our image signal processors to do HDR right without ghosting. And we have significant advantages on multimedia power. So again, that example of if you put more CPUs in and you don't have a DSP, your music playback scenario is not going to be very good. We have 30% longer playback of music because we're more efficient using our digital signal processor to do that. And this is the statistical output. If you go into the rooms that are next door and adjoining, you can actually see this benchmark running. So this is the score from GL benchmark for Snapdragon and our Taiwanese competitor. In some ways, this is the least important thing, I will tell you, even though you're all taking pictures of it. I'd encourage you to go take videos of it running next door, because that's what consumers see. They see, does my game play smoothly, or does my game drop frames, and does my game stutter? So look at this benchmark run, not just the output. This is my friend PJ. We're taking HDR pictures of him. PJ's not that fast, but he's apparently faster than this particular competitor because he's quite blurred. He's almost ghost-like, but he's not as fast as Snapdragon. These are all, by the way, photos and statistics from commercial devices. This isn't sort of demoware type stuff. I'm going to skip competitor B because it's hard to find them in a phone, and I'm going to go straight to competitor C and talk about graphics performance from the competitor from Korea. Again, actually, surprisingly, 3x the performance lead here. Again, superior camera features, things like built-in support for laser autofocus, which delivers much better photos. I'm going to drill into panoramic here, which is something we do quite better. And then, of course, our product has end-to-end 4K support versus just 4K capture. And we think end-to-end 4K is a premium tier feature. Here's the output of the benchmark. Again, I would encourage you not to look at the numbers as much as I would encourage you to look at the user experience. That's what we all see every day when we use the phone. You might run a benchmark once on a phone, but you run apps and games all the time. That's what matters. And so we have 3 times the results and significantly better graphics performance. Here is a very exciting picture of the Qualcomm parking garage. We'd like you to know we didn't use professional photographers to simulate something you couldn't do yourself. And up at the top is competitor C from Korea. Certainly you can see when you look at that zoom in, much lower resolution, but it either appears that there's been an earthquake in Southern California and the garage is broken, or they don't know how to stitch the photo together properly. And I'm going to say it wasn't an earthquake, because I probably would have gotten a call. So that's just a quick example of the statistics and then really the user experiences that are possible from the Qualcomm approach. Importantly, as I sort of wrap up, I do want to remind you that part of the Qualcomm approach in Advantage also is that we do this across product tiers. The way we're able to afford the significant R&D investment to do features like LTE and LTE-advanced and carrier aggregation and all of the work we do on graphics is because we build for the premium tier first, but then we very quickly cascade that down to the affordable tiers as quickly as possible. That's critical. We're the only company that's offering category 4 LTE in our entry-level product, and we've been doing that for a while now. And all those features like the graphics and multimedia also cascade down. So we invest at the high tier and then we make it available. The other announcement that I want to cover that we made this morning as well is a collaboration with Allwinner. So you probably all know Allwinner is a very successful participant in the tablet market, really in the mass market Wi-Fi connected space. And in this collaboration, you're going to see Qualcomm and Allwinner bringing interesting value to each other. For Qualcomm, Allwinner brings us access to a part of the tablet market that we had not participated in as strongly as we wanted. And Allwinner brings a channel as well as design expertise. For Allwinner, what Qualcomm is bringing is a premium product, a premium brand, and LTE. And so we'll be enabling Allwinner to bring affordable tablets connected with LTE to the market to more and more customers. For perspective, the LTE attach rate in tablets in the market right now is about 30%. Qualcomm's LTE attach rate, because of our leadership in that space, is 60%. So for both companies, we see an opportunity for incremental business. For Allwinner, we'll help take them into new parts of the market, and they'll do the same for Qualcomm. So this will be a fun thing to see how it develops over time. And finally, if you go to the second demo room, which is around the corner, you're going to get a chance to see a bunch of things, and you'll walk in and you'll realize there's no phones in here. That's intentional. Qualcomm's begun talking about our traction in the Internet of Things, and it's not just talk and slides, but it's actually real. We have, in the last calendar year, sold over $1 billion of products that we grew up and were born in mobile and have customized for IoT into the IoT space. It's everything from cars to the control and automation gear for the home to consumer networking and enterprise networking. So there's over $1 billion of Qualcomm sales now, and our view of this opportunity for us is about 5 billion devices in 2018. So it's exciting times because the leadership we built in mobile will continue to invest in, but we're taking those technologies into adjacent categories. And it's just like the video that we started with, when we connected to the phone to the internet, it got smart. We're doing the same thing with a whole host of other devices, and that's part of the fun of what we get to work on. So with that, I want to thank you for your time. I'm going to hand off to Urban Guy, who's our Vice President of Product Management, and he's going to take you into multimeter MIMO in much more detail.
Good morning, my name is Urban Guy, and what I want to talk about is how wireless connectivity is actually improving rate, capacity, and performance, and then also give you an overview of how these innovations from Qualcomm are actually improving the user experience as well. So let's first map key wireless technologies that enhance that user experience by frequency. With 11AC, there's been even a much sharper push towards 5 gigahertz, and this trend in this frequency band will continue with future technologies such as 11AX and LTU that Tim alluded to as well. And then there's millimeter wave, which is frequencies in the tens of gigahertz. And this is an example of the frequency band that 11AD is deploying it today. Now, if you take a look at how we view these both technologies from a Qualcomm perspective, they're very, very complementary solutions. For example, with 11AC, what you're doing is it's the same Wi-Fi that you love and use today, evolving to give you better performance. And 11AD gives very, very high throughputs, but the use case for both are different, and we'll talk about that as well. Now, 11AC gives you the similar range as you were used to with previous versions of Wi-Fi, but it increases the speed, the capacity of your network, and then it also acts the Wi-Fi system more like a cellular system, which is able to support a lot of low-power devices together for a more efficient network. 11AD, on the other hand, gives very, very high throughput, but it has a more modest range. So some of the applications for that technology would be docking, for example. You take your smartphone and it acts as your home entertainment system by connecting to your television. Another use case for 11AD will be it can allow you to transfer content very, very quickly onto your mobile device as well. If we take a look at 11AC in specific, as consumers, we started getting access to multi-user 11AC Wave 1 devices in 2013. What that represented in 2013 was a 3 times capacity increase over 11N devices. And the reason this was enabled was your channel density went from 40 megahertz to 80 megahertz. Your encoding techniques improved to 256 QAM, and we leveraged explicit beamforming. 11AC Wave 2, the one that we're talking about today, and I'll show you is in production, improves that Wi-Fi performance even further. What it does is, by 3 individual steps, it brings about multi-user MIMO in the 5 gigahertz band. What that means is your access point or your home gateway uses its antenna resources to connect to multiple clients simultaneously, and I'll show you that graphically in a little bit. The other thing 11AC Wave 2 brings is it increases the number of spatial streams that you can leverage in your device. For example, with a 4x4 11AC access point that you will be able to see in the demo in a little bit, your peak PHY rate increases to 1.7 gigabits per second. Now, if you go back and take a look at where you were on 11AC Wave 1, a 3x3 product was at about 1.3. So there's a big lift what you're getting just from that one feature. The other advantage 11AC Wave 2 that Qualcomm is in production with right now that you get is we double the RF channel bandwidth. We go from what was 80 megahertz in 11AC Wave 1 to 160 megahertz in Wave 2, and as you double that bandwidth, your data throughput also increases. So from a Qualcomm perspective, our customers that are leveraging these technologies are able to use all these features in 11AC Wave 2 that we're in production with to increase the performance and the capacity of your Wi-Fi network in the home, in the enterprise, in venues like airports, stadiums, benefiting the consumer. Why and how is this possible? Well, let me explain to you what multi-user MIMO, that feature we just talked about, means for you as a consumer. Just in 11AC1, when you did not have multi-user MIMO or competitors that do not implement multi-user MIMO, the device would actually work. One device at a time. Your access point will connect to one device, then another device, then another device, then another device. And what that means is, if you had a device like a 3x3 laptop, you were able to use the full access points bandwidth. But if you had a one-by-one client like your cell phone, all that extra bandwidth was wasted. And I'll show that to you graphically in a little bit. What multi-user MIMO does is, it allows you to bring back the simultaneous transmission to multiple clients from the same access point. So that's the benefit. You're not going one client, another client, another client. You're able to group the clients, and you are able to offer a simultaneous connection to multiple clients. So there's no downtime for your access point. It's giving you a better performance. And this improves the network capacity in the same environment. Why do we need multi-user MIMO now? If you just think about it, where you were a couple years ago and where you are now with your personal life, you have a lot more Wi-Fi connected devices. There is a big competition for the shared bandwidth that Wi-Fi provides. And what we are offering over here is, if you take a look at 2.4 band, that's already saturated. The 5 gigahertz band is also starting to get overpopulated. What we need to do is, with that same resource, how can we use it better? Now, if you take a look at our research, it shows that the average home will have about 20 connected devices in 2020. By the end of this year alone, we expect the installed Wi-Fi base of devices will be roughly 5 billion devices. All that puts pressure on the network. And as this rapid proliferation of devices increases, there's the need to improve the network's use of spectral efficiency. This is what multi-user MIMO provides. And if you look at the right-hand side, the majority of the Wi-Fi devices that we use today are tablets, they are smartphones, and fewer devices like laptops. We do more on the smartphone devices. And given the power and size constraints and the space constraints in a mobile device, many of those mobile Wi-Fi clients are one-by-one. So if you can improve what you get out of that one-by-one client versus a larger device, you save your power budget, you you save your cost system, and you also save your package size, and you can make those thin devices clients that we all love. And multi-user MIMO works very well with 1x1 devices or 2x2 devices. Here's the reason. If you have a multi-user MIMO access point that you'll be able to see, and I'll show to you graphically as well, that one multi-user MIMO access point is able to connect to at least 3 of those multi-user clients simultaneously, and it's able to offer one spatial stream to each of those clients at the same time. So what it would have taken you 2 to 3 times as long, you're able to do in one instance. And that gives you a multi-user MIMO benefit of 2 to 3 times capacity increase of your network. That's the advantage of multi-user MIMO. And what we're talking about here is not just what you're going to see a year from now, or you're going to see 18 months from now, or 6 months from now. Qualcomm is the industry leader in shipping 11AC Wave 2 multi-user MIMO devices now. And not just in one segment. We have enabled the full ecosystem. You have infrastructure enterprise customers like Aruba HP, Ruckus. They have already launched devices. So when you go to an airport or go to a hotel or a sports venue or an office building, these devices are already available. They're shipping. If you use a carrier gateway at home, companies like NEC, AVM, are already shipping carrier gateways with 11AC Wave 2 from Qualcomm. If you walk in and buy a laptop, Acer, Samsung are already shipping multi-user MIMO devices as well. If you go and buy a retail gateway, D-Link, TP-Link, Linksys are all shipping Qualcomm-based 11AC Wave 2 technologies as well. And of course, mobile phone vendors, client devices like Xiaomi, ZTE, HTC from Taiwan have all launched products with multi-user MIMO as well. And it's just the tip of the iceberg. In the next couple months, you will see a lot more multi-user MIMO-enabled products in the market. And this is current devices. And at this show, we are very excited to launch our second generation of 11AC Wave 2 products from Qualcomm. Whereas our competitors are just going to be announcing and launching and sampling their first 11AC Wave 2 products, we just showcased the entire ecosystem that Qualcomm has enabled, and we're launching the second generation of these products. The two products are Qualcomm 9994, which is an enterprise access point market for the infrastructure space. And then at the same time, we are also enabling the QCA 9984 for the home gateway market and the carrier market. So the full ecosystem as well. They have enhanced features like multi-user MIMO with both explicit and implicit beamforming. You also have 4 streams. With 4 streams, your peak PHY rate increases to 1.7 gigabits per second, and you have wider channels. So before, you had 80 megahertz channels. Now you have 160 megahertz channels. And the advantage of that is as the RF channel bandwidth increases, so does your data throughput. It's a wider highway. You can send more information through that. One of the things that's unique to Qualcomm's implementation of 160 that our competition doesn't offer is we can have a full 160 channel, but if there's an interference or a disturbance in that Wi-Fi channel, we are able to break up that 160 to 2 parallel 80 megahertz or 2 parallel highways to avoid that interference and still get the full benefit of the extra bandwidth that 160 provides. And the best thing is for our customers that I showcased to you that have already launched our products, these 2 new devices from Qualcomm are package compatible. That means our customers can use that same R&D investment that they did to get those first products to market to get these out as well, which means faster time to market for consumers. With this chart, what I'll explain to you is just a recap of multi-user MIMO, like what's already shipping in the market, and then what our 2 new devices offer to the market today. This is an example of what multi-user MIMO does. On the left side of the slide, it's an example of multi-user MIMO. On the right is the traditional single-user approach. In the single-user approach, even if you had this great new 4x4 access point, you would only be able to connect to a 1-stream device, like a cell phone, or maybe a 2-stream tablet, or a 3-stream laptop. but you would only be able to connect to one, then the next, then the next, then the next. With multi-user MIMO, you don't have to wait. Your access point doesn't have to wait. It's able to do this simultaneously. So you could just have 3 clients or a tablet and a client connected in the same transmission slot. The advantage is there's no downtime. You are able to use that bandwidth that would otherwise get wasted all at the same time. And that's the advantage of multi-user MIMO. With our new devices, the benefit is in the blue. With the new devices that we mentioned, the 9984 and the 9994, we increased one spatial stream or another channel or lane in the new device. What that offers you is you could have a 2-stream client, a 1-stream and a 1-stream. So like a tablet, a client, a mobile, or you could have 2 tablets. And the reason this new device is so important, in addition to the 160 megahertz channel we supported, this extra stream, because as time goes on, you will have more higher-end phones with 2x2 Wi-Fi chips in it supporting multi-user MIMO, or more and more tablets that support this feature. So this device takes your investment from our first wave and extends that leadership into the second wave of 11AC Wave 2 multi-user MIMO as well. This is another unique feature from Qualcomm. In the products that we launched today, they support what we call butterfly MIMO. And it's very, very simple for you as a user to benefit. The benefit is that you can be close to the access point and get great performance on your Wi-Fi device, or you can move further away and still get that great performance from your Wi-Fi device. And the reason it's called butterfly MIMO is when you are close to the access point, you have like a 2x2 antenna at 160 megahertz channels. And as you move further away, like a butterfly, it opens up to 8 antennas to give you that increased performance with the 8 channels in an 80 megahertz channels. As you come back closer, it can revert back to 2 antennas at 160 megahertz channels. Very, very flexible, and it can do it at a packet-by-packet basis, which makes it a very flexible architecture. Butterfly MIMO, another unique advantage from a Qualcomm product. So what we'll do now is we will showcase to you a demo of how this is actually better than some of our competitor solutions. On the left, what you see is a Qualcomm multi-user MIMO 4x4 access point, and it's working with 1x1 Xiaomi client cell phones with multi-user MIMO. There's 3 of those connected. And if you take a look at the computing setup, it's a Broadcom-based gateway, and it actually has 2x2 11AC single user clients. So 2x2s, more expensive, more power consumption, larger size, and 1x1. And the performance benefit that you will see is that we get 1.9 times better performance on the 1x1 MU client versus the traditional 2x2 larger, more expensive SU clients from Broadcom. We will show you a video that will walk you through it. I'll pause a couple times to show you the results, and then after my presentation, the Q&A, you'll be able to see it live over here to take pictures and ask questions as well. Let's roll. So this shows you the router that's going to increase the performance up to 3x from Linksys. It's available in the market for order and purchase. And we'll be using Xiaomi 1x1 clients. Again, Xiaomi phones are available in the market, ready for purchase. With 2 clients, your performance is actually increasing to 530 versus before. If you put 3 clients, your performance again increases to a factor of 1.9, you will see, at 650 megabits per second. So the clients added to the access point, the performance keeps rising, gives you a 1.9 performance increase over an SU mode. So just to recap real quick, what we showcased to you over here was one 4x4 access point. You add 1 client, you get the performance. You add a second client, instead of the performance for those devices going down, you're actually increasing the overall performance to a factor of 1.5. With 3 clients, the overall network performance increases to 1.9. Let's roll. Now you're going to see it in comparison with the Broadcom MU-MIMO device. The Broadcom devices are 3 clients with 2x2 11AC products. The router throughput on this side is 650, 22% better than what Broadcom is able to do with 3 clients access to a gateway with 2x2 versus 1x1. So the key messaging over here is at 1x1 does not necessarily mean that it's going to give you a lower performance than a 2x2 solution. It all depends on how you're using the spectral efficiency. Multi-user MIMO enables that and allows you to get more with a smaller size, more cost-optimized product. We can go to the slides. And this will be live over here right after the presentation. So from a Qualcomm perspective, the key message takeaway is multi-user MIMO is real. The benefit is tangible. The performance can be anywhere from 2x to 3x in the system. It's not something we're showing as slideware. These products are shipping in all the different segments: infrastructure, carrier, retail, computing, consumer electronics, as well as mobile devices as well. And the key message as you walk around afterwards and take a look at the demos over here and next door are not all Wi-Fi is equal. When IEEE creates these 11AC standards, they just create the specification. They leave it up to us as vendors and companies, how are we going to implement those algorithms? This is where the Qualcomm advantage kicks in. Our R&D folks have been working on these algorithms the last 7 years, and this is one of the reasons why we are already shipping multi-user MIMO while competition is just introducing their first product, and we are launching our 2nd generation of 11AC Wave 2 at this conference. Thank you very much.
Okay, we're running a little short on time, so I will go through the 3G and LTE connectivity slides fairly quickly. So I want to encourage you all to ask questions when we have our Q&A session if I go over this too quickly. One of the things I wanted to point out first is that this is a week of firsts for Qualcomm, like many weeks we've had in the past during these events. I want to call out some technology demos that we're doing for the first time. Actually started in Beijing last week, and we've basically moved all this equipment here. First uplink carrier aggregation demo on a commercially shipping product. We're the first in the world to show that live on Snapdragon X12 LTE modem, otherwise known as the 9X45. So you'll see that live. That doubles the uplink throughput on that device. Snapdragon 425, the device that we believe will drive volume for a carrier aggregation Cat6 worldwide. You'll see the first Cat6 sessions being done live on that chipset, the newest Cat6 device in our portfolio. And finally, Cat9 on the Xiaomi Mi Note Pro device, which had been announced earlier in the year. We actually showed Cat9 working live on that device for the first time in Beijing. Again, that was last week. We brought it here for you to see. You can come see those demos next door. In addition to the competitive benchmarking demos that show examples of what Tim pointed out in his presentation versus a couple of our key competitors. Just to go back to the Snapdragon X12, it is our flagship modem. We've consistently been in the top tier in our thin modem category, a generation or several generations ahead of our competitors, and the Snapdragon X12 is no exception. First commercial device with both Cat9 and Cat10. And so if you look at the perspective of what we've done in driving technology leadership in 3G and LTE modems, we've improved the ability, the download time, the speed of download, or let's say the improvement in waiting time to download content by a factor of 250 times over the course of 10 years. In other words, going from the early days of 3G to where we are today in, and I don't have a laser pointer here, all the way out to the right side of the chart, 450 megabit per second Cat9 in this X12 modem. I don't want to just talk about feeds and speeds. As Tim pointed out, there's a lot more involved, but if you look at the, just the simple fact, across our first 3 generations of carrier aggregation product, we've not only improved the download speed by a factor of 3, we've now with the Uplink CA, improve the ability to upload your content to the cloud, and that has been one of the biggest bottlenecks of many carrier networks around the world, especially in dense areas like sporting venues or sightseeing tourist locations where people are taking both 1080p and 4K photos and videos and uploading. The improvement in the uplink is quite astounding, doubling the speeds. But I think even more significant is the ability to drive these improvements and constantly get a power improvement across these 3 generations of products. So we've actually reduced power by a factor of 40% in just 2 generations. And this is an apples to apples comparison. We take the same mode that's common to all 3 products, the 20 megahertz carrier aggregation in Cat4, and we measure that across these 3 generations, and we see a 40% active power reduction while we're delivering these enhancements in terms of downlink and uplink speeds. And so let me put some metrics on what Tim described as the user benefits here. At the end of the day, what really matters is delivering the better user experience. And nothing describes that better than the amount of time a user has to wait, either watch their video buffer as they're downloading, or wait and watch the throughput freeze their entire device while they try to upload these massive files. And so if you look at some of the metrics, this is just downlink, but again, in the uplink, we're improving the upload speeds by a factor of 2 now with the Cat 10 capability, the uplink CA. We're looking just from Cat 3 to Cat 4 to Cat 6. Just look at these metrics in terms of these seconds of waiting time. Everybody's experienced this, not wanting to upload. Wait till you get to a Wi-Fi access point because you don't want to freeze your device while you're waiting for all this content to get downloaded. That's one aspect. The other one is the ability to enjoy richer quality images and video on your devices too. So you have this better experience. You're actually going to do things that you can't do on our competitors' devices. Not just because the AP is better at creating richer content, but we've actually got the connectivity to do that immediately. Applications like WeChat, Moments, you can't actually upload those immediately as the application requires unless you're in the presence of an access point. So what good is that if you don't have this pervasive 4G connectivity with these kinds of speeds for very popular applications? And so when we look at the traction among the OEM community, you see those user benefits. It kind of tracks with the amount of traction we're seeing in the OEM community, because these are really important features that enhance the user experience. They're big differentiators. And we have different tiers of carrier aggregation going from Cat 10 all the way down to Cat 4 in the lowest tier product. So it's no surprise we've got 70 OEM designs worldwide and 40 alone in the pipeline in China. So the 70 number comes from GSA. That's a third-party research report. We've announced several designs in China. You've seen some of the OEM announcements, Xiaomi, LTE, LG G Flex 2, and other devices out there that support Cat 9. But this is just a sampling of some of the devices that you'll see in the market. Tim talked about operator benefits as well. And because of some of the compelling, enhancing user experiences that the carriers can now offer with the carrier aggregation, operators can offer, let's not confuse the term, and the network efficiency benefits that allow operators to deliver richer content at a lower cost per megabyte. It's no surprise we also have immense carrier traction around the world. The 115 operators investing worldwide, 64 carrier aggregation networks have already launched, and emerging as a common denominator now across the world, just as Cat 4 has become basically table stakes for any smartphone in the market around the world. Cat 6 has become the key differentiator, and we believe in the volume tier now, in this coming year or two, Cat 6 will define the minimum requirement. And if you look, 53 of the 64 networks that have launched already support Cat 6. Competitor A, as Tim pointed out, has not implemented carrier aggregation in any form yet, much less even Cat 4. So it's not just about the few flagship features that Tim showed in his slide, but I'd like to point out also that once features are introduced historically in the mobile business, because you have this very long tail in emerging markets and trailing edge technologies in some markets, these features don't go away. We just keep building them up, and we have to retest them, redevelop them every time we introduce new silicon. And if you look at our flagship tier product, we have about 2,000 modem features in those products. It's astounding. If you think about it across 2G, 3G, and 4G, we're not only introducing these very complex new features, but we're bringing forward into new silicon all these old features, and they have to work just as well, in fact, even better. As Tim pointed out, we constantly reinvest in 3G, making power and performance better in techniques like interference cancellation and power management techniques, while our competitors just stopped investing in 3G. And the numbers show everything, and you'll see them next door in some of the 3G demos as well. But if you look at what's driving these feature enhancements, it's feeds and speeds and the number of bands in LTE. We all know radio spectrum is very fragmented in LTE, but there's also carrier aggregation techniques, proprietary features like interference cancellation that give these performance advantages. So that's what I call the feeds and speeds set of features, but also one of the hidden complexities in LTE is supporting voice on an LTE device. There's about 18 different ways or modes of voice in an LTE smartphone. The vast majority of voice is still carried over circuit switch cellular, 2G or 3G networks. So when you're on an LTE data session, you have very complicated switching mechanisms to revert to 2G and 3G voice seamlessly, and that's one of the reasons you saw those high call failure rates with our competitors. These are very complex technologies that users just take for granted because on a Snapdragon device it works almost perfectly every time. And so voice is a complexity that continues with the advent of VoLTE and video telephony and all the services that go on top of that. In addition, there's some real revenue enhancing services that constitute some of these 2,000 features in our phones, like LTE broadcast, bringing in premium content, very high quality live video, advertising opportunities, and other applications. So it's not just about the 2,000 features that we lead with in terms of feature richness and the ability for a device to take advantage of all the features that are deployed around the world, but we have to test these features across a number of different OEM devices. And what this slide basically shows different phases of chip development, and collectively the number of modem tests that our typical chip has to pass in its lifetime. So the 1 million modem tests on average for a typical Qualcomm chip across all of the different OEM devices. And the bottom of the screen shows you all the different phases of development, from the time we get the chip back all the way through to the commercial chipset certification that some operators do, the leading operators do, to the modem tests that our OEMs have to pass, and we need to support and help them debug when they merge our chip with their software. So it's an immense amount of scale that we have in terms of commercializing software, modem testing, and support of our customers all the way through to launch. And then finally, not to be lost is the point Tim made about designing everything as a system. This picture really sums it up best, that it's not just about the baseband, which some competitors like to talk about. It's about the collective set of chipsets that constitute a complete solution that has everything from connectivity to location integrated, power management, enhancements in the front end that improve performance and power, like an envelope tracker, which reduces LTE power, antenna matching tuner, which combats the death grip that people make on their phone, and you tend to lose a significant amount of power. The antenna tuner can actually compensate for those kinds of things, and a number of different options like audio codecs and NFC that enhance both the audio and connectivity capabilities of the device. But it's a system-level approach that we actually take utilizing the collective IP, and we own all of this IP, unlike many of our competitors that have to outsource a lot of this stuff. So we can design everything as a system and optimize each of the components to work both to extract performance and power advantages, as we've shown. And I'd encourage you to, again, take a look at the technology demos we have next door, and also the competitive benchmarking demos that we have in the private demo area as well. Thank you. And John?
So what we're going to do is we're going to move into the Q&A portion. We're just going to get set up here for it. We're going to invite Tim, Peter, and Erwin to come back up to the stage. And then what I'd ask is we have Claudine over here. We have Lori back there with microphones, who will be able to walk around and make sure you get a mic to ask your question. I would ask that you please identify yourself and limit it to one question. We're only going to do this for about 5 minutes because I want to give people ample time to see the demos, and then you, of course, can ask any additional questions we may have at that time. So if I could ask our panelists to come back up to the stage and have a seat, and we will move on to the Q&A portion. So, questions? Lori, and then we'll come up the front right after that.
Hi, Charlie from Semi-Accurate. Question on MU-MIMO. It's just starting to be rolled out now. When do you expect it to be across all markets? You know, you can walk into a place and expect to see it. Got a rough time frame?
So, Lori, next one up here.
So from a production standpoint, what we're seeing is that all the different segments, at least the key OEMs, have started launching the products right now. In the enterprise space, Aruba and Ruckus have publicly launched. We expect a couple more of the very large enterprise OEMs to be announcing shortly based on that product. In carrier, we have AVN and NEC that have publicly launched. For the big carrier gateways, given what the cycle is, it's usually a 6 to 9 month qualification cycle. It will probably be Q1 calendar when the product is commercially available. In mobile manufacturers, you already have Xiaomi, HTC, ZTE publicly launched, and we expect 3 more towards the next couple months as well. On the computing, you have Acer and Samsung that have publicly launched, and I think in the next 2-3 weeks you should see a few more make noises on their ramps as well. In consumer electronics, I think it will be more as we get close to the Christmas 2015 cycle. And just one quick point, and if you take a look at what's in these solutions, Qualcomm is really leading the way at least about 9 months in that multi-user MIMO space. And what we're announcing today is the second generation of those products. Thank you. Thank you.
Hi, Devinder from Engadget. I'm just wondering if you guys could elaborate on the Allwinner collaboration and kind of what that means for both companies. When can we start seeing those products? And I don't know, we also saw Intel partner with Rockchip. Wondering if this is a similar sort of deal. How do you think it compares?
There we go. So the collaboration's already begun, and I think that probably the most, and the details will be in the press release that just went out. I think the most important thing to note that's not in the press release is a question I got the other day, which is Qualcomm making an equity investment? That's probably one that people ask because it's one of the ways people have been driving business in this market. And the answer is no. The way we're driving business is with mutual wins because Allwinner has an important channel to market and Qualcomm has a leading product. We aren't having to buy business or buy distribution. And that's probably the most important thing is this is organic, and that's why we think it's going to work.
And then get you all the James availability.
Anshul with more insights and strategy. It's actually a follow-up to the Allwinner question. What would you say is the main reason why Allwinner would implement your SoCs in their, tablet designs if they've already got their own SoCs? What makes it attractive?
I'll start, Peter, if you want to jump in. I think the key thing is integrated LTE. And that's as the market transitions, and particularly as LTE literally explodes in China, integrated LTE is a competitive advantage. And an SoC without integrated LTE is going to have a much harder time being successful. And so that's probably the genesis of it. Secondarily, brand, I think, is also important. Allwinner sells to a lot of global brands that really care about the quality of the product and the ingredients that their brand's getting associated with, and Qualcomm also brings that along.
Next questions? Yes.
Hi, my name is Wolfgang from Chip Magazine in Germany. I'm just a little bit confused. You mentioned Cat4 a couple of times as an example for carrier aggregation. To my knowledge, it's not aggregating carriers.
So actually the first carrier aggregation products that were produced were done for the earliest operators that have deployed LTE, namely in the US, Japan, Korea. And the reason they had a challenge is they ran to market very quickly with LTE with the spectrum that was most available nationwide in those areas, particularly in the low bands, to very narrow bandwidths, typically 5 and 10 megahertz were the bandwidth limitations. In those bandwidths, you can't support Cat4. You actually need carrier aggregation 10 plus 10 megahertz to actually get to Cat4. It's actually the first wave of carrier aggregation products were Cat4 and continue to kind of define the low end. Now those markets are very mature, markets like North America. They're demanding that same feature all the way in the bottom tier, which is why we brought it down to Snapdragon 210. So now we have carrier aggregation Cat4, 10 plus 10 megahertz in the low end, and continue to bring the more advanced carrier aggregation features starting at the high end with Cat 9 and Cat 10, and those will eventually cascade down as well. But the answer to the question is, the spectrum that was deployed initially in many markets, not just North America, if you look back to the earliest operators like Docomo and others, AT&T, Verizon, typically 5 and 10 megahertz of spectrum were deployed for the first bands that got launched in those markets. And so the demand for carrier aggregation occurred first in those markets just to get to the full Cat4 data rates of 150 megabits per second.
This is Agam Shah with IDG News Service. This is for Tim. You mentioned, this is about the Allwinner deal. You mentioned that you'll bring access to the channel market and access to the design market when you talked about the deal. Could you elaborate on both, especially access to the design market and who's going to use whose designs?
We'll clarify a little bit. Allwinner has a successful channel to market, a customer base that they sell to already. And what this deal brings to Qualcomm is access to that existing channel of customers that Allwinner already has developed relationships with. And that's not a channel that Qualcomm directly engages with ourselves.
And it's focused heavily on connected tablets.
Does that mean Allwinner is going to actually use Qualcomm designs in its chips? Or is it limited to the LTE part?
It's a focus on LTE designs with LTE connected tablets using Snapdragon.
The 210 and 410 for the 2 series of products. Additional questions? We have 1 or 2 more before we wrap up. 1 more?
Edward Chester from Trusted Reviews. Could you just quickly summarize the specific advantages of the second generation Wave 2 router chips that you just announced over the first generation?
Sure. So from the Wave 2 11AC multi-user MIMO, there's a couple key advantages. One is we add the channel bandwidth up to 160 megahertz. That's one versus the 80 megahertz. The other key advantage is that the 160 megahertz channel can actually be broken up into 2 separate non-contiguous 80 megahertz channels. And the advantage of that is if you have interference from a Wi-Fi standpoint, this gives the access point flexibility to avoid that interference and still get the benefit of 160 megahertz bandwidth. And the third benefit, of course, is that you have the butterfly MIMO, which allows that access point to adapt. If you're close, it can give you high performance through 2x2 160 megahertz. As you move further away, it can revert to 4 antennas, 80 megahertz channel, and still give you performance at an extended range.
Do we have a final question before we wrap up? I will take silence or lack of hands up as a no. And with that, we'll wrap up. Thank you, everyone. Thank you, Tim, Erwin, and Peter. I encourage you to see the multi-user MIMO competitive demos here, the cellular and AP competitive demos next door, and the IoT demos in the adjacent room. So thank you for coming. We appreciate you taking the time to spend with us this morning.